This is tutorial 8, question 4, part 22, and we'll begin with 22a. In this question, we're given ax equals to lambda x for some scalar lambda, and x is an eigenvector of a. And we're asked whether this is true or false. Now, the answer is false, and the reason is because x must be non-zero vector. So that's the key. Alright, lambda, the eigenvalue can be 0, but x must be a non-zero vector because a multiplied by a 0 will be equals to lambda multiplied by 0. This is a 0 vector. So we are not interested in the trivial solution. So the answer is false. Alright. In the question, it says v1 and v2 are linearly independent eigenvectors. Do they correspond to distinct eigenvalues? And the answer is also false. We can have repeated roots. So we can have lambda 1 equals to some value alpha, and lambda 2 is equals to alpha, and then they have independent eigenvectors as well. So maybe as an exercise, you can try the question 555, which was in the previous question, and we realize that lambda equals to 0 is repeated. We have two eigenvalue p1 and p2. That would be the solution of the homogeneous equation, and therefore we have two distinct eigenvectors for lambda equals to 0. In this question, it says that the eigenvalue of a matrix is on the diagonal. Now the answer is false. This is only true when the matrix A is upper or lower triangle or diagonal. And in the last question, the eigenspace of A is a null space of a certain matrix. So the eigenspace of A basically means that the space spans by the eigenvectors. Now, who are the eigenvectors? Remember, ax equals to lambda x, and we have ax minus lambda I, x equals to 0, a minus lambda I, x equals to 0. So the null space of this matrix, let's draw it in green. The null space of the above matrix is actually the eigenspace. And we are done. Thank you.